Perfect. Yeah. Thank you so much, first of all, to Neo4j for being here, and Jason for organizing this, and Luke for the introductions. And it's great to be discussing about how do we leverage graphs, not only for the knowledge bases, but how do we optimize collaboration between agents and even agencies. And we'll be discussing that today. So a bit about myself. I'm originally from South Africa. I then immigrated to study at UT Austin, and during my time at UT Austin, I started to really get interested into neuroscience. And we'll be discussing a bit about today, touching on, the inspirations and how that led into the creation of memory, which leveraged Neo4j and was a big proponent in this graph RAG push. And then, discuss about fine tune and how we look about using graphs to represent computational workloads, and how we look to optimize collaboration. So yeah, just at a high level, I think we want to structure this for about 15 minutes speaking, and then 15 minutes Q&A, and would love to hear thoughts from the community. But yeah, we'll be discussing on a bit about Marvin Minsky and the roles he's played in MIT Media Lab in around 1980s, speaking about, okay, if we have the structures of memories within our brains, how do we relate that to agentic memory, and discussing about the constraints and how we overcame that. And then leading into looking at graphs to represent computational workflows, how do we now optimize those workflows in the different phases? So, I mentioned at UT Austin, I got interested into neuroscience. And specifically, I got interested into how humans form memories. How do I form a memory? How do you form a memory? And how does it differ? And a lot of the research I came up to was led up to Marvin Minsky. Marvin Minsky was a cognitive and computer scientist that actually co-founded the MIT Media Lab. And he focused on how does our brain, or the thought processes, actually collaborate while being independent and being very focused as an independent agent. How do they collaborate to solve complex thoughts and complex actions that we as humans take? And he launched a book called Society of Mind. And if you haven't read it and you're interested in agents and graphs and memory, I definitely suggest reading it. And at a very high level, what Marvin Minsky proposed was looking at how do you have separate agents work together to form agencies, and then actually how do those agencies work together to now actually act. And he's portraying this idea within that this all happens in the sub-millisecond level within our brains. And what he proposed was that even though they're independently strong, how they work together is how they achieve these harder, more complex tasks. And this came to mind when I was reading this. It very much was in the time where agents were starting to become a really a published idea upon research, but still the memory to what these agents were constrained by were really low. And this was back then. So you had Llama 3 8B be at 8,000 context window, or Mistral 7 being the same. And back then 3.5 Turbo was just a 16,000 context window. So it was about how do we take these structures of memory that Marvin Minsky proposed back in 1980 about how our brain is structured and how our thought processes work together, and represent that in a certain way so that agents can benefit from the structure. And that's what led into memory. In my final year of college at UT Austin, my final semester, we looked at how do we take these learnings and apply them to very constrained models. And we did this with Neo4j at its core. What we did was we understood how to represent a memory modules that gather the information that represents what is a user's breadth and depth of knowledge. Because if we could understand serving agentic applications, what our users were exposed to, what did they know really well, and what did they not know so well? And we did that by running agents, keeping track of the responses from the users, and actually creating up these entity stores to then later on use these entities as context stored in these knowledge graphs to then offer more personalized responses. And without Neo4j and knowledge graphs here, we couldn't keep track of the entities and the relationships and start inferring what does a user know already to personalize responses. And this did pretty well. We launched it, we open sourced it, and it's gotten over 1,500 repo stars, around the same number for package downloads, and we're over 900 clones right now. So, if you're building an agentic system, and memory is a key part of how you interact with your users and want to personalize responses, take a look at our repository. The QR code is there, fully open source. We do some community contributions, and we've recently partnered with other graph databases. So really, this is at the core of how do you personalize these responses. And then we looked at, okay, representing these entities and understanding these users' breadth of knowledge is great, but how do we really leverage graphs to make agents more robust and more performant? So we take a strong look in that whatever workflow your agent is represented as, is executed as, we can represent that same workflow as DAGs, where each node represents an operation, an LLM call, or even a output result. And what we do is we focus on how do we actually backpropagate throughout this workflow so that anything going into the system, what we call an entry node or parameter node, how do we then allow that input to be optimized to achieve the evaluation? And this idea of parameter optimization is really a stepping stone to what we focusing on with graphs at its core, and Neo4j helping along this. We're looking at initially, optimizing the parameters of a single agent, and how do we get that very robust, that single agent workflow. So be it system prompts, be it actual functions. How do we actually do code generation or rewrite your prompts so that it's been optimized for the evaluation? Once we have this, we can look into not only the parameter optimization, but the communication channels. How do we optimize those so your agents, in the same way that your mind works and what was proposed by Marvin Minsky, can be optimized? And then it's about scaling that to channels between agencies. Once you've formed very optimized, robust agencies. And then once we've got that, we'll look at building a small world model, but that's definitely for another discussion. So diving into the first optimization where we use graphs, what we do is we represent your workflow, be it any Python workflow, as a graph, as a DAG. And we see how do we go from whatever parameters you've put into the system, whatever feedback, like reinforcement learning for neural nets, how do we use that feedback to optimize the parameters? And until we succeed in the goal of this workflow, how do we keep optimizing those parameters and make sure your workflow achieves the goal it's set out to do? And we do this by going from the output node and actually performing backpropagation all the way to a parameter node. And with that, within using the likes of Neo4j with graphs, we can start understanding relationships of these computational workflows, and we can start understanding what is the context we need to offer a suggestion for optimization. And we do this by, as seen within these iterations, is that we backpropagate each node until we get to the parameter node. And if you take the idea that this optimization for a single agent and figuring out how to optimize the parameters, you can have a multitude of optimized workflows. And once you've gotten those workflows very optimized in an independent state, you then refer to the ideas of how do we take these independent siloed agents like Marvin Minsky proposed, and actually have them collaborate together. So given a very multi-hop complex task, how do we then optimize the collaboration of these specific independent, highly optimized agents to complete a task? And that's the second phase of the optimization. How do you place distribution, probabilistic distributions upon each communication channel as you run this within this agency, and eventually learn what are the correct structures that the agents are supposed to be placed in, and the execution topology, to then being able to now have a successful execution for a longer task. And the same could be applied, the same theories could be applied when not only with optimizing the communication between a single agency and also known as a multi-agent system, but how do we now take many agencies, be it 5, 6 different agencies, and optimize the communication channels on a higher level execution? And this could be seen in real world sense as how do we take large enterprises and their different organizations and allow them to communicate and collaborate together. And those ones have been fully autonomous. And we're very excited to see how do we apply the same distributions and the probabilistic distribution of that, how do we apply it on this high level structure, and where we could take these proposals from Marvin Minsky's work and actually represent them in a certain way to achieve higher order intelligence. And to emphasize these graphs, be it when you create a graph that represents an agency or represents a single workflow, or even many agencies for optimization of the communication channels, having a graph database that is robust like Neo4j actually provides its benefits in how we achieve all of this. And we're very grateful that it's very robust, and what they've put out is very strong to our research and considerations. So yeah, our current state is that we can optimize any parameter, as I mentioned, system prompts, actual functions of a single agent. And we've releasing a beta group to test within that. So if this is of interest and you're running workflows and specifically agents, and you want to optimize them and make sure they achieve an outcome, you can definitely scan the QR code for the beta group and check out what we're doing and stay in touch. As well as, if you're interested, reach out. But we're taking this step as one of 4 major phases, where we're looking at next, how do we support agencies? So many agents within one single agency and the optimization, the communication channels between those. And then how do we do that at a high order and eventually get to the small world model? So, I'll leave this up for, but if you're interested in optimizing your workflows, or, just in general, how do we get to this higher order of intelligence by representing what actually works within our own minds, please do reach out.